Well, what is it that this is mounted on here?
That's called a foundation. Chick has to come up with a design of an M12 50mm hole spacing on a common grid. They're designed specifically for the machine that you're working with to maximize the work envelope utilization. And literally, you can take on and off that quick lock and put it in the exact same location, just like you would if you were playing Battleship, let's say.
So sorry, that's very important, isn't it? Because you're machining jaws to suit the job. Mm-hmm. When the jaws go on the base needs to be in the same place every time, doesn't it? Because then you're preserving the datum and your whole setup stays set up, doesn't it? Okay.
Exactly.
Sorry, I interrupted you there.
Don't remember what I was going to say.
All right.
So our demo models here are made from aluminium. What are the actual ones that are going to be supplied made from?
We obviously made them aluminum because we don't want to kill our sales team. Yeah. We take these and show them all across the world. But when you go on the machine, we want to use something that's a cast iron. The reason for that is that the table itself is cast iron. As temperature changes, the thermal dynamics between the cast iron table and the cast iron foundation connected off a total of 40 inches, say by 20 inches, let's say. As that thermal dynamics takes place, you'll have literally thousands worth of difference between the table expansion and the aluminum plate on top. So we've chosen to go with cast iron because the cast iron will have the same thermal dynamics.
Right.
Okay. So now you might ask, well, we have an aluminum base sitting on a cast iron plate. The difference is it's not 40 inches in length. Okay. And that long distance isn't there, and the location points are about this far apart. So that's a much smaller distance, and it doesn't have the same impact.
Okay, so I also noticed that round the foundation, you've got the zones for clamping using the toe clamps. Is that your only option for fitting these to a machine table?
No, actually, when we send these foundations out, they're designed specifically for the machine they're going to go on.
Okay.
So we can maximize the travels of the machine and maximize the work envelope space within the machine. So each plate is designed specifically for the machine it goes on. And we provide all the bolts and everything to bolt it down. So when you go to put this on your machine, it will actually have hold-down bolt holes, and we'll provide the toe clamps and the bolts to bolt it within the T-slot itself.
All right. Okay.
Okay. So then you fit the foundation. I'm assuming you then clock it up square to make sure that it's properly aligned to the machine axis. Bolt it down, and from that point on, it never moves. That's your new surface for clamping all your work holding onto. Right. And that gives you a precise location for whatever you want to clamp.
Correct.
And every time you clamp it, it goes back in exactly the same place, and your datums are all preserved, and it's very quick because you're not messing around with clamps and trying to find bits of threaded rod that are the right length and packings and things like that. You've got these, every 50 mils, you've got an M12 hole to clamp in, as well as a bushing, which gives you a precision 12mm hole for location. So each hole can be location or clamping or both.
Correct.
You could use shoulder bolts to clamp a fixture down, or I think Chick do have a special location device, don't they?
We have expanding pins that would go in. So you drop the pins, you turn the handle, it will hold itself in place, so that way you can slide things on and off, and that's not going to fall
interesting.
out. Yeah.
So because it's expanding, I would imagine then is zero clearance between the pin and the foundation once you've tightened it up.
Yes.
So the only clearance you then have is whatever goes onto the pin. So you kind of eliminate a layer of potential error by doing that. So you don't get that stacking up of tolerances.
It's minimized, yes.
Minimized, yeah, okay. Pretty well thought out system. Okay, so we're clamping 2 parts at a time here on the quick lock.
Correct.
Do you see customers putting more than these on the machine table? I mean, if you've got a foundation, it's covering the whole machine table, you could probably get
multiples on there.
Multiples on there. Right.
Yeah, and it's very dependent upon the customer's part volume, part density. So if they're doing a batch run of 2 parts, that's probably what they're going to do.
Right. Because that's roughly the same space, I suppose, as a traditional vise would take up on the milling table. So you often see machines with more than one vise on sometimes. So I would imagine you could put more than one of them on too. Yeah.
Yeah, and the more quick locks you put on there, then obviously the more you can amortize that tool change time over.
Right.
So typically we'll see between 2, i.e. 4 parts, or upwards of 4 plus on the table. The reason why is that the tool change time, each time you put an additional part on there, so we go from 1 part to 2 parts. If my tool change time, let's say, is chip to chip, say 10 seconds, let's say 8 seconds. Chip to chip, 8 seconds. I put 2 parts on there, then my tool change time per part goes from 8 seconds per part. Now I put 2 parts, goes to 4 seconds per part.
Right, yeah.
Right. If I go now and double that out again, so now I have 4 parts, then my 8 seconds divided by 4 parts gives me 2 seconds per part. If I do that and double that again, so now I have going from 4 parts to 8 parts, I'm down to a second per part. Okay. And you can see how it becomes an exponential decay.
Right.
So the return on this no longer is saving time, it's more creating walk-away time.
Right.
Where the machine will run for longer periods of time unmanned, and the machinist can get more done, and we can get a higher percentage utilization of our machine.
Okay, right. So in that situation, then you've got more walk-away time. You've got a longer cycle, producing more components, but then the operator, he doesn't have to be there
Right.
as many times in the day. It makes his job easier. It makes it more, he can do his inspections comfortably. He can keep his machine tidy.
Yeah.
He's not having to be there every few minutes.
Right.
Because the machine can just keep running
Exactly.
and producing parts
Yeah,
without that labor required. Right.
Yeah, so it becomes the machinist becomes more efficient. One of the things we see globally is that finding skilled labor, people that are really knowledgeable in manufacturing, is becoming harder and harder to find. So now what we've done is we've created an efficient environment where the machinists can walk away and do other things. Instead of me having to go hire 2 new machinists because I have this new job, the machinists can continue to do what they normally are doing, but they're doing it in a more efficient manner. And that allows then the company to become more profitable and the machinist most likely to earn more money.
Yeah, that's interesting though, because you do sometimes see with engineering companies, when they start running out of capacity, the go-to solution is to put another machine in.
Yes.
Very often on credit.
Yeah.
And then put another operator in front of it. And the total cost of that is very high. And it's a recurring cost because you've got the labor cost, an annual salary to pay for. Whereas if you just looked at your current process and looked at how much you could make that more efficient, how much more capacity you could generate with the equipment you already have on site, that's almost always a better approach, isn't it?
Yeah, and even if you were to add a piece of equipment, but your existing team can continue running that extra piece of equipment, it's a finite cost. Eventually that will be paid down. And so you're not adding, when you add labor, you're adding $60,000, $80,000, $100,000 a year with labor costs to your business, depending on the caliber of the machinist. So, and that's an annual thing you're going to see every single year. If you have a person that's very capable and you give them an extra machine, now that individual who's making $80,000, $100,000 a year, that individual now can go and run a second machine because we've given him these great tools. And so now he's worth more, and the machine is worth, and the company's making a lot more because all I had to do was put the additional machine in place.
But it's actually technically less work for him because he's able to walk away. He's not having to go back.
Yeah.
So one lock, quick lock. We're still talking about sort of vertical machining centers here.
Yes. Yeah.
Where does Chick fit in with the horizontal machining centers?
So what we've got is this. We take the System 5 concept here. We've taken it and flipped it up on its end and put 4 of them back to back. You could see how that would look like a tombstone.
Yeah.
Okay, we have a single piece of aluminum extrusion that has all 4 sides with the same interface to it.
Right. So it's not bolted onto a column, it's actually built in.
Exactly.
Right.
And so the benefit with that is that it's much more compact. It's also very solid. And as I tighten it up, it actually becomes more rigid as an overall unit.
Really?
Yeah.
Okay.
Yeah.
So that was my thinking. Like when you're attaching work holding to a column on a horizontal machine, you're getting further away from your point of contact and your gripping forces. Whereas if everything's solid and attached at the base, and it is the actual base of the pallet that is holding everything strong, and then you've got that squeezing technology on your jaws, you're just creating a solid, sturdy environment.
It's a very rigid system.
It would need to be because it's only supported on one end.
Right, exactly.
Yeah.
Exactly.
Okay.
And then all the things that we just talked about with the quick lock will work there. Those single station, dual station, face plates.
Right.
and we do those standard wide, tall, and oversized jaws. So all the different things that we just talked about here work. The advantage in the horizontal is a couple-fold. First one is you see the quick lock, we're typically showing a part where you machine here and then you machine the opposite side. When you go into, there are times that you have to do machining on the part. You know, let's say that I'm dealing with this, I have to machine here, here, and here. How do I go about doing that? Well, on a horizontal mill, you can see how I go here. I can rotate this, I can get access to it this way, and this way. And so with a multi-lock, we now make it easy for a customer to be able to hold and machine on all 6 sides of the part in 2 clampings.
Right.
And the accuracy, precision of the machine is now developed and put straight into the part that way. Okay.
Yeah, I mean, if you're using this sort of idea as well on a horizontal where you could have op 1, op 2,
Exactly.
you're now not putting parts down on the floor and you're taking away that chance of error from moving it around because your jaws were machined at the same time and they were located at the same time. It has to be in the right place.
And typically you'll go with op 1s on one side and op 2s over here. So now you can amortize the tool change time like you're saying.
Yeah, exactly that. Yeah, so you could, even if you did 0 and 90 degrees as op 1 and 180 and 270 is...
You would typically do 0 and 180.
Yeah.
And then on 90 and 270 to the op 2s. And the reason being is you unclamp the one and just rotate as the column comes around, you put them in place.
Yeah.
So
that's interesting. So if you're doing, for instance, work where you would normally need a fixture on a tombstone in a horizontal machine, when you're not doing that job, you've got to take that whole tombstone off.
Correct.
And store it somewhere.
Right.
Whereas here you've just got these top jaws that just come off.
Correct.
But this one is going to catch you out here. In this operation, in this sort of way of working, it's irrelevant. But when that's stood up on its end, how am I holding 2 parts when I undo it?
So when you're standing it up like this, you turn the handle, you have 2 parts. So what I'm going to do, I got to hold these 2 parts and somehow turn the handle.
Yeah, exactly.
So we built in what we call a third hand mechanism. So what ends up happening is, as I turn this handle, one of the jaws will open, the bottom jaw will pull down first. So I just take this part out first. The top jaw is still held with a spring force holding the part in place until I turn the handle again, and then I can take the top part out.
Right, so it's got a spring tensioner built in?
Yeah, already built in.
And is that even for using in a horizontal way like this, if it's mounted horizontally on the table?
Yeah, it can be used. The whole system comes with that third hand mechanism built right in.
All right, okay.
Yeah.
Okay, interesting. And I believe, though, it is also possible to mount the multi-lock instead of on a horizontal machining center on a pallet. I believe it's possible to mount in a 4th axis vertical machining center as well. So does that give you something similar to a horizontal machining center's sort of levels of productivity?
Yes, especially if you had a pallet changing system on that table, absolutely.
Right.
But even without, you're getting the benefits of the 3 sides part access, holding more parts, the amortization over bigger quantities, so therefore less per part.
Right.
It's a really good solution. We call that an indexer subsystem is what we call that.
Okay, I see.
Yeah.
And then you provide one that suits the 4th axis someone already has fitted on their machine.
Yeah, that's a very good point. Thank you for asking that. We have there are many people that make really good indexers out there, and so we take your indexer and then we have designed to it a specific package for that indexer.
Right. Well, just a fit, ready to fit.
Yeah, it all goes together. All the tools, all the parts, everything you need.
And then you're getting all of those same benefits of having finished parts coming off every cycle.
Exactly.
Right.
Exactly.
Hitting 3 sides of each part and having 8 parts. So all 6 sides on 4 work pieces every single cycle.
Yeah.
Yeah.
Fantastic. And you mentioned before about tombstones and putting tombstones on the table. If you have true tombstone work, which means you don't clamp it, you try to put straddle clamps or something to hold it down, or toe clamps or however you want to do, you could take the faceplate concept and put that onto the multi-lock. And they've converted a clamping system that clamps this to a tombstone-like device. But now to change it out, you just turn the handle and pull the faceplate off. Right. It's much, much simpler, much, much more cost-effective.
Absolutely.
Yeah.
You don't even need special lifting equipment because it's just a little, lightweight piece of aluminium. Just stick it on, turn the handle, and you just loaded whatever parts. Yeah.
Exactly.
So one of the things that I have often wondered about, Chick, is with the size ranging, obviously you've got a very definitive, the 50/20 up to the 15/50. What was the thinking with the increments?
Okay. So we have the 50 millimeter product, the 100 millimeter product, and the 150 millimeter width. That's the jaw width. Each of those products can go one size up. So in the 50 millimeter jaw width, it's 50 millimeters wide, but we go up to 80 if you wanted to.
Okay.
On a 100 millimeter system, you can have 150 millimeter wide jaws. And on a 1550 or the 150 millimeter system, you can go up to 200 millimeters wide. Okay. By doing that, we've covered a large range of the different types of parts that people manufacture. On top of that, we have the ability now to hold small pieces and get close access to them, as well as something much bigger.
So, I mean, for most of this, we've talked about 3-axis machining, whether that is on a vertical or a horizontal.
Sure.
A lot of people are now taking the step into 5-axis work.
Correct.
Where can Chick sort of find itself placed in the 5-axis world? Is it relevant in the 5-axis world?
Yes, good question. What we've done is we have customers that are buying the foundation from us. That's the first thing. So they have the unified interface that they can mount to. On top of that, they can use quick locks on there. They can use the multi-locks and get all the volume benefits of having amortized all that inefficiency over more work pieces. And then if they're using a central clamping system they enjoy, they can put that on there as well. So what you have is the versatility of being able to run and use the right tool for the right job, if you will.
Is that something you don't see very often, is people doing multi-component clamping on 5-axis machines? Correct. I've noticed everybody's using centric vices and doing parts one at a time.
Correct.
Why can't you combine the benefits of the axis of the 5 axes with multi-component efficiency? I
think what it is a lot of people, they feel stuck with the centrics. They get into the centric vice holding, and they sort of feel like, right, we've put into this
committed now,
and we can't sort of. So we're going to find a way to make it work within this work holding, not realizing that they can actually use multiple different types of work holding.
Yeah.
And they don't have to get rid of the new centric vice that they just bought. They can use it alongside this for different work.
And so when you have that, what you got is a customer that, if I go to a company that has a vertical mill or a 5-axis mill, and they're running jobs on it currently, and I say, look, take that off and put our stuff on there, the customer goes, you're crazy. I've got 50 jobs already set up to run this. I can't just go and change it up willy-nilly because it takes forever. And that's where this quick change system comes into play. Is now they can use the foundation. They can go quickly on and off that foundation, and they can use a centric clamping system. They can use a dedicated fixture. They can make large parts, or they can put the quick lock or even the multi-lock on there. And we have a number of customers that are doing that and being very successful with it.
Yeah, because a lot of 5-axis work is actually, it's about access,
yes,
rather than actually how you rotate the table. So if you can get more parts with the same amount of access, I mean, it's a no-brainer. Why would you not do that?
Absolutely. What I see is that probably 70% of the work that's being done on a 5-axis mill is really 3+2.
Yeah, I've noticed that as well.
It's not truly volume production.
5-axis interpolation.
Yeah, exactly.
It's 3+2. Yeah.
Yeah. So with that, given that, then you can see how if you have the versatility to use the right tool in the right job, the Chick system on all the stuff that's doing 3+2 work is ideal. Going to the single station clamping system, you're going to a centric vise.
Yeah.
That's perfect when you're doing all your 2-axis and 3-axis moves.
You need the center of your workpiece over the center of rotation for that kind of work.
Absolutely.
Yes. But for 3+2, it's not really that relevant, is it?
Exactly.
But yeah, a lot of times, if the customers that I see, if they're doing snap-off work, centrics are perfect. Because you machine everything, you snap it off, and that's it, job done. It goes away for rumbling or whatever the next process is. But when they're doing 2 operation work where they have to make that change, they're losing time.
Sure. And
they're losing efficiency, whether they're undoing the vice and changing the complete vice. that door's still opened. The machine still stopped, the spindle stopped turning. But if they had a multi-lock, let's say, with the faceplates on it, they've got access on a 5-axis to any part of that faceplate.
Absolutely.
And they can maneuver it, program it. All the models are available.
Yeah, absolutely.
Without the door ever having to open.
Yep. Makes perfect sense. And the thing that a lot of times you'll see is that people are, what they're doing is that they're taking that same inefficiency we talked about at the very beginning and putting that now. I've got five sides of the part. The advantage of the 5 axis is I'm putting in one part. Sometimes you get the code out of the CAD system and you run that one part. When that one part is run, all those tool changes are amortized over one part. The cycle time on that is going to be significantly longer than if you had 2 parts in a quick lock or 8 parts on a multi-lock. Okay.
It makes perfect sense.
Thank you.
So I suppose one last question. In the future, what can we expect to see from Chick moving forward? I mean, this stuff is all about productivity improvement, efficiency through work holding. Where are we going? Where's Chick moving forward?
Well, what Chick does is we look to innovate where there's nothing that's already in that space.
Right.
So the areas that we really want to focus our attention on at this point is the same kind of putting the right tool for the job in front of the spindle. And that's where we're putting our attention to right now.
Right. So are there new products in development right now that we might be seeing?
Absolutely new products in development.
Okay. Something to look forward to.
Steve Jobs taught me a great quote, which is, the worst type of leak to have on a ship is a leak from the top. So I'm not going to ruin our rollout of that product just yet. Okay.
Yeah, well, it's been great talking with you, Paul. It's been an insight for me. Like I've learned some stuff today about the units that even I didn't know about. So thank you very much for your time.
I appreciate it. Thank you.
Very good to see you again, Paul.
Thanks, mate.
Really appreciate that.
Yeah,
Hope to see you again.
It's been a lot of fun. Thank you.